We are looking at another method for solving quadratics. These two problems are set up to take the square root of both sides. The square root of a plus 4 squared comes down as a plus 4, and we get plus or minus 7. Now we split our equation, so we have a plus 4 equals 7, and a plus 4 equals negative 7. Subtract 4 from both sides. We're going to solve both equations, and we're going to get a is equal to 3 or negative 11. Now for our next one. Take the square root of both sides. The difference here is 13 is not a perfect square. So we leave the right-hand side plus or minus square root of 13. So when we subtract 5, we cannot combine these terms. They are not like terms. So we have negative 5 plus or minus the square root 13. So that is solving using the square root method. I want to use that same method, and I recognize that I have a perfect square trinomial. So this factors into x plus 4 squared with the 7 on the other side. So if I have a perfect square trinomial, now I can move to the square root of both sides. X plus 4 is equal to plus or minus square root 7. Subtract 4. X is equal to negative 4 plus or minus the square root of 7. Now we recognize this as a perfect square trinomial. This factors into x plus 5 squared equals 7. Take the square root of both sides, and I get x plus 5 equals plus or minus square root 7 minus 5. X is equal to negative 5 plus or minus square root 7. Now let's look back at how we recognize that we have a perfect square trinomial. We take the 8, we cut it in half to get this number right here, and then we square it to get the 16. We take the 10, we cut it in half to get the 5, and we square it to get the 25. So what if we don't have a perfect square trinomial? Then we can convert it to a perfect square trinomial. I want this to be x plus 4 squared. In order for it to be x plus 4 squared, then this has to be a 16. So to convert this polynomial into a perfect square trinomial, I'm going to add 6 to both sides. Now I have my perfect square trinomial. So this factors into x plus 4 squared is equal to 13. Square root of both sides. X plus 4 is equal to plus or minus the square root of 13. Subtract 4 from both sides. X is equal to negative 4 plus or minus square root of 13. Next, if I want this to be a perfect square trinomial, that this is going to be x plus 5 squared. So I need this number right here to be 25. So to make a perfect square trinomial, I'm going to add 15 to both sides. Now I factor my perfect square trinomial into x plus 5 squared. Take the square root of both sides. X plus 5 equals plus or minus square root of 22. Subtract 5. X is equal to negative 5 plus or minus square root of 22. Next, I know that I want a perfect square trinomial. That means I want this one to be 16. So I'm not going to add to both sides. In order to get my perfect square trinomial, I'm going to subtract. So I'm going to subtract 11 from both sides. Now I have my perfect square trinomial. Take the square root of both sides, plus or minus the square root of 19. Subtract 4. X is equal to negative 4 plus or minus the square root of 19. Last one. I want this number right here to be 16. So I'm going to subtract 3 from both sides. Factor my perfect square trinomial. Take the square root of both sides. X plus 4 is equal to square root 7 plus or minus square root 7. Subtract 4. X is equal to negative 4 plus or minus square root 7. So that's how we are using our knowledge of perfect square trinomials to solve these quadratics.